Good morning, students. Today we are going to discuss about the topic recursion. Recursion meaning repetition of some process. Solving in a computer term, recursion means solving a problem by following a repeated procedure is what is the meaning of recursion. Okay, there is a term called recursive functions. Recursive function means a function is a function that will call itself again and again to solve a particular problem. That means a problem is divided into sub-problems, and those sub-problems are solved in the uh, same way in which the bigger problem is solved. Okay, so by solving the bigger problem is solved by dividing the problem into smaller ones and applying the same procedure to this for solving the same divided problems, and finally those problems will be combined together. Okay, I mean, for those solutions will be combined together to provide the solution to the bigger problem which was split earlier. Okay, so always the recursion concept is well explained using a tower of Hanoi puzzle. Okay, so I'll just show you the tower of Hanoi toy which is available in the market, which is bought by parents for children to play. Okay, so in ancient days, people this type of structures were there in the temples. Okay, where three kinds of pegs will be there. Okay, so the people used to move the disc from one of the peg to the destination peg with the help of the auxiliary peg. Okay, so I'll just explain how to play with this tower of an eye toy first. Okay, so this tower of an eye toy will be having three discs. Okay, the one of the disc is known to be source peg. Okay, so here it is written as A. Okay, the peg named A is the source peg, and the peg named B is said to be destination peg, and the peg named C is said to be auxiliary peg. Okay, so the job is to in this puzzle, the job is to move all these discs available in the source peg. We have to move all these discs to the destination peg. Okay, so this is what is the job. Okay, so how to move? We have to follow by following two rules. Okay, we have to move the discs from the source peg to the destination peg. Okay, what is the first rule is that, okay, so we have to move only one disc at a time. Okay, so only one disc at a time. Okay, so this is what is the first rule, and the second rule is we should not keep the we should not keep the bigger disc on the smaller disc. Okay, this is what is the second rule. Okay, so smaller disc மேல என்ன பண்ணக்கூடாது, bigger disc வைக்கக்கூடாது. Okay, so this is what is the second rule. Okay, so this can be accomplished, these two rules can be followed and for moving the disc to the destination with the help of the auxiliary peg will help us to follow the rule number 2. Okay, so let us see an example. Let's take only 3 discs. Okay, tower of an eye toy with only 3 discs. Okay, so for differentiating the discs, okay, so these discs have been colored, shown in different colors. Okay, so the red color disc is the bigger disc. Okay, the green is smaller than the red one, and blue color is the smallest disc. Okay, so all this is the source peg, so we need to move these discs to the destination peg, and this is the auxiliary peg as said earlier. Okay, so we need to move all these discs to the destination peg. Okay, so let us see how to move. Okay, so I have said already, so in order to move, we have remember the two rules. The first rule is to move only one disc at a time, and the second rule is to second rule is not to keep the bigger disk on the smaller disks. Okay, these are the two rules we need to follow. Okay, so we have to move all these three disks to the destination. How to move? We cannot move directly, isn't it? We cannot move the red disks directly to the destination, because these two disks are on the top of the peg, right? Okay, so in order to move this red disk to the destination, we have to move these two disks to the axillary. Okay, so axillary, if we want to move these two disks to the axillary, we have to follow. We cannot move these two disks at a time to the axillary, and hence we have to move this particular disk to the destination, and then green disk to the axillary, then blue disk from the destination to the axillary. Now we will have green disks and blue disks on the axillary, and we will have red disks, only the red disk in the source peg, so that can be freely moved to the destination. Okay, so I'll just show the pictures of these movements. Okay, so we have moved blue disk to the destination, green to the axillary, and blue to the axillary. Now the source peg is having only one disk, which can be freely moved from the source to the destination, which has been moved. Okay, now so what we need to understand is, so when there are n number of disks on the source, we need to move the n minus 1 number of disks to the axillary peg. N minus 1 number of disks to the axillary peg. After moving, if we have moved n minus 1 number of disks to the axillary peg, we are ready to move we are free to move the nth disk to the destination. Okay, so the problem can be repeated, okay, with a new source and new value of n. Okay, in earlier iteration n value was 3. Okay, we just played the game like that. Okay, so now the new n value is what? New n value is, it is 2. Okay, now this becomes the source peg, destination remains same, and this becomes a axillary. Okay, so now we need to move this nth disk. Okay, this is what is the nth disk. Okay, we need to move this nth disk to the destination. So when you try to move this nth disk to the destination, there is one more disk on the top of this particular disk. Okay, and then we need to move this n minus 1 disk to the axillary, then this nth disk to the destination. Okay, so after that you will find new source and new axillary. Okay, so I'm just trying to move this particular nth disk, that is green disk, to the destination. In order to do so, I'm just moving this blue disk to the source. Moving this blue disk to the axillary. Now the source is having only one disk, which can be freely moved from here to destination. Okay, so it has been done. Okay, so again you have to understand, in order to move the n minus 1 disk, nth disk to the destination, we need to move the n minus 1 disk to the axillary. Okay, that is what is the logic. Okay, the problem recurs again. Okay, so now this becomes a new source, destination remains same, and the new axillary is this one. Okay, so we just try to move the nth disk to the destination. Okay, so when you count the number of disks here, okay, so number of disks here is only 1. Okay, so when the source peg is having only one disk, okay, the problem is simpler. Okay, so we can directly move from the source disk to the destination. Okay, So when there is only one disk, the disk can be moved from the source to the destination directly. If there are more number of disks over the last disk, okay, that is biggest disk, then those n minus 1 number of disks should be moved to the auxiliary, then the nth disk to the destination. Okay, that is what is the logic. Okay, all right, now all the disks have been moved. Okay, so this is the recursive code of the Tower of Hanoi problem that we just discussed. Okay, so when there is only one disk, okay, we can directly move that particular disk from the source to the destination. Okay, if there are more than one disk, okay, we need to move the n minus 1 disk from the source to the auxiliary, then nth disk to the destination. Okay, all right, okay, then nth disk to the destination. The problem reoccurs with the newer n minus 1 number of disks. Okay, so I hope you guys understood what is recursion and how it can be understood with the help of the Tower of Hanoi toy. Okay, thank you so much for listening, and here I have given 2 video links for your better understanding. Please watch these two. Please visit these 2 links and watch the video. Thank you so much.